gives us the function f of x equals x cubed plus x. All right? And here it says graph the function and locate its extremes and zeros and explain how they're related to the monomials from which it's built. Okay, do you guys understand the question? So first let's graph it. That's the first thing, okay? And here's what we're going to do is I'm going to graph this x cubed plus x. Okay? And we're going to look at this. And I'm going to throw this little blue ball, and whoever catches the ball has to answer the question that I'm about to ask you. Okay? Ready?
That was the no one.
You have to catch the ball.
The wall has to answer.
Okay, who has the ball? No, keep it. All right, so we'll try this again. Catch it. All right, so I've graphed it. What, are there any extreme values? Is there a minimum or maximum in this graph?
No, there's not.
No, there isn't. Okay, throw it back. All right. Put your hands up if you want to catch the ball. Otherwise, I'm just going to hit you in the head. Well, I'll just throw it.
Drill someone.
Oh. Just so we're going to amend the rules. Whoever the ball hits has to answer the question. Throw it back. Is there another way I could represent this function?
No.
Yeah. Do you know what that way might be? No. Yeah. We could pull an x out, right? We could say x squared plus 1. Okay. Does that help us at all in any way? No. What other things can we determine by this? Okay. I'm going to throw the ball. Please catch the ball this time. Oh. All right, so now, what is the end behavior?
Down and then up.
Well, yeah, but what, so when we talk about the end behavior, so I'm going to be a little more formal. The end behavior of this function, and I think I misspelled behavior, but that's okay, we'll fix that later. What is the end behavior? Well, we're talking about the limit as x approaches infinity of f of x. So when we look at the graph, hold on you guys. Who threw that?
I'm not throwing it.
Shh. All right, listen. Shh.
No, I told you to.
Yeah, it almost hit Mr. Adams. We're trying to learn though. The end behavior, as this function approaches, hold on, as this function approaches positive infinity, what does the y value do? What is that approaching? Infinity. Now, if I take the same function and I approach negative infinity, what does my y value approach? So if I start going this direction, what am I approaching in the y direction? Negative infinity. Is this bounded? No. Okay. So here's some more questions. What is the domain of this? All real numbers? Yeah, there's no restriction. What is the range of this? Yeah, and so we could, and I heard somebody blurt it out, and I'm glad that they said it. Somebody said, well, you could just say negative infinity to positive infinity. Yep. You certainly can. So then let's talk about this. There's no extremia. The factors, these are the factors. If I set those equal to 0, what do I get? If I say x times x squared plus 1 equals 0, then I say x equals 0. and x squared plus 1 equals 0, and then I get x squared equals negative 1, or x equals the square root of negative 1. Can I do this one? Can I find this? Can I solve that? No. So I only have one real solution and one imaginary solution, right? And it has an imaginary component. Really, we call that a complex solution, right? Because complex numbers have a real component and an imaginary. The real component is 0, the imaginary is I, right? But it didn't ask us about anything other than that. What else can we tell by the graph? What else can you tell by looking at the graph? What else do we know about it? Let's look at the table of values. So if I look at the let's look at the table of values. If I look at the table of values and I plug in negative 1, I get negative 2. If I plug in negative 2, I get negative 10. But if I plug in positive 1, I get positive 2. If I plug in positive 2, I get positive 10. What type of function is that? Does anybody remember? I heard it. It's not even. Good guess though. It's not neither. It's odd. So it's an odd function. Because when I plug in the negative x value, I get a negative y value. In other words, here I'll show you. If I plug in 10 on an odd function, my y value is 1010. Now, if you had to guess, what is the y value when x equals negative 10? Should be negative 1010. Let's go see. It sure is. Okay? All right. That's all they wanted us to do, is just graph it and talk about the behaviors and try to explain it.